Hi everyone, welcome to another episode of Harvey Teaches You Chemistry. Today, amino acids. As you can probably tell from the name, all amino acids have an amine group and a carboxylic acid group, and the ones that we specifically need to know about for the A-level chemistry course are the amino acids that are found in the human body. These all have the structure shown on screen where the amine group is bonded to the second carbon. And they also all have their R group coming off of the second carbon. This means that they all show optical isomerism around the second carbon because there are 4 different groups bonded to that carbon, except of course for glycine, because glycine has an H group on there, so there's 2 H groups, which means it doesn't show optical isomerism. If you guys don't remember, this is called a chiral carbon. These are also referred to as 2 amino acids or alpha amino acids because the amine group is bonded to the second carbon, so you number the carbons going from the carboxylic acid group. One of the key features of amino acids is they form Zwitter ions. This is a type of ion that is neutral overall but has oppositely charged ends, and this occurs because of an internal transfer of a proton between the basic amine group and the acidic carboxylic acid group. So the hydrogen from the carboxylic acid group drops off and gets picked up by the amine group, causing one end to become positive and the other to become negative. As you can imagine, having both acidic and basic ends on your Zwitter ion causes some interesting reactions with acids and bases. I think we're going to first take a look at an acid reaction. In this case, the excess hydrogens bond back onto the acidic end of the amino acid, causing us to form an overall positively charged ion, with the hydrogen still bonded to the basic end and our normal carboxylic acid group at the other end. The opposite occurs if we mix the Zwitter ion with a base. In this case, the base picks up the hydrogen ion from the amine group and leaves us with a negatively charged ion, where the carboxylic acid group is still missing its hydrogen. If you're struggling to remember which reaction happens in acids or bases, as in which way round the losing or gaining of a proton is, then you can use this handy method of just counting up the charges, because the charge has to always be conserved. Next, we're going to talk about the isoelectric point. This is the pH at which the Zwitter ion is neutral, as in the pH at which there's a positive and a negative charge on both ends. And we can test this by using thin layer chromatography. We want damp filter paper with a potential difference applied across it, and we dot our amino acid in the center of it using a pencil line for reference of where it is. We can then, the potential difference will then pull it to one side or the other if it is charged, and then we can dry it off, add ninhydrin, and heat it to see where the amino acid was. This whole process is called electrophoresis. So if we have a neutral Zwitter ion, the forces pulling it towards the positive electrode and the negative electrode will be equal, so it won't move off of our dotted line. Whereas if we have a Zwitter ion in either an acidic or basic solution, because they become positive or negatively charged, then the force will pull them one way or the other. So in this example, the negatively charged one gets pulled towards the positive electrode, and the positively charged ion gets pulled towards the negative electrode, because opposite poles attract. The properties of amino acids are very similar to the properties of ionic compounds because of the Zwitter ions. They form crystalline structures with high melting points in their solid states because of the attraction between the positive and negative poles on the Zwitter ions. These positive and negative poles also mean they dissolve well in water, and as we have touched on before, they also undergo optical isomerism due to the second carbon being chiral carbons, except for in... The next part of the amino acids topic is peptides, polypeptides, and proteins. This is slightly more biological than chemistry, but we still need to know about it. So, amino acids can form peptides, which are just 2 amino acids joined together from an amide linkage. And an amide linkage is a condensation reaction between the carboxylic acid of one amino acid and the amine group of another. The OH of the carboxylic acid and one of the H's from the amine group drops off to form water in a condensation reaction, and an amide linkage is formed between the C double bond O and the N from the amine group. And naturally, if removing water forms them, then adding water can break them apart again. So the opposite of a condensation reaction is called a hydration reaction. This is when you add water to the amide linkage to reform the two separate amino acids. This is not something that happens naturally, so we have to add 6 mol per decimeter cubed hydrochloric acid and boil it for 12 hours as a catalyst, or we can use an enzyme. These are biological catalysts that don't get used up during reactions but speed them up. Enzymes are another topic we can cover in a separate video. If you would like to see that, leave a comment below. These peptides can go on to form polypeptides and then proteins, and we need to know the structure of proteins as part of the course as well. They have 4 types of structures we need to know: primary, secondary, tertiary, and quaternary. We're going to first look at primary, which is basically the sequence of the amino acids in the chain. So this means what order are the amino acids joined together in. And this is normally denoted using the 3-letter symbols of the amino acid, simply drawn as a train. So like this example here, I can't exactly remember what these 3-letter symbols refer to, but that's an example of a primary structure of a protein. The secondary structure is the shape of these chains. So we have beta pleated sheets and alpha helixes. You may have heard of alpha helixes before. They are the structure of DNA as well. Alpha helixes are spirals, and beta sheets are anti-parallel chains of peptides. This means that they are running in the opposite direction. These structures are both held together by hydrogen bonds. The tertiary structure is how the whole polypeptide chain folds to form its final shape. This is caused by several interactions between the R groups on the chains. We have ionic interactions between basic and acidic side chains. We have hydrogen bonding again, like in the first one. This will be between nitrogens and hydrogens, or the oxygens and hydrogens. We also have van der Waals forces, and finally disulfide bridges, which is when 2 sulfurs drop their hydrogens and form a covalent bond between them. We don't need to know the mechanism of how disulfide bridges forms, we just need to know that they exist. The quaternary structure is something you'll very rarely be questioned on, but we still need to know about it. It is how different polypeptide chains interact and fold to become the full proteins. So we're going to look at an example of hemoglobin, in which case there are 4 polypeptide chains, 2 hemes and 2 globins, I believe, denoted by red and blue, although I'm not sure which one is which. We can look inside the hemoglobin and see some alpha helixes. Unfortunately, there are no beta pleated sheets to show how they're shown on diagrams like this, but also you can see the tertiary structures. In this case, the blues and red sections indicate different tertiary structure, and the quaternary structure is the whole molecule. Finally, I think it would be wise to touch on the amino acids that get given to us in our formula books and just familiarise ourselves with them. They give us 1 amino acid with each type of side chain. So the first one we're going to look at is one with a sulfur side chain. As you can probably remember from previously, these sulfur side chains form disulfide bridges between each other. So the hydrogen will drop off of this sulfur and the sulfur on the other sulfur side chain, and a covalent bond will be formed between the 2 of them. We don't need to know the mechanism of how this works, we just need to know that it does. I think the one that's given to you in your formula book is called cysteine. I'm going to write the names of them next to each other, but I'm not going to try and pronounce them all, so they're there for you to read if you want to. The next group is the acidic group. These interact with amine groups and form ionic bonds between the acid and the base, because the proton is donated to the base to create a negative acid group and a positive basic group. The final 2 groups are far simpler to understand. We simply have an amino acid with a benzene ring on the side of it and an amino acid with an alcohol group on the side of it. The benzene ring doesn't have many interactions with other amino acids. You just will get asked questions about benzene with it, and the alcohol group simply undergoes hydrogen bonding. And that concludes the amino acids topic. As usual, this document will be in the description if you would like to add it to your own notes. I'd be interested to know if you guys prefer this document layout versus the poster layout, so do leave a comment and tell me which one you want me to do in future videos. Also, if you do have any questions, don't forget to leave them down in the comments and I will try and get back to you and give you some answers. Also, leave a comment if you have any topics that you want me to cover in future, be it in physics, maths or chemistry. Thank you guys for watching. Don't forget to hit like and subscribe, and I will see you next time.